generate a grid map. Okay, so if you are doing blind docking or else you are doing targeted docking, you need to generate the grid maps. So we are going to generate grid maps. We are going to prepare the receptor and the ligands. So for that, for preparing the receptor and the ligands, we are going to use a tool called Autodoc tools. Okay, so this comes under the MGL tools. Okay, so when you install these MGL tools, you'll be also installing the Autodoc tools. So some other tools application are also get installed when you install the MGL tools, but what we are going to use is the Autodoc tools. Okay, so using Autodoc tool, we are going to prepare the receptor as well as the ligand. Okay, now when you install, this is different. Okay, MGL tool is for just preparation of the receptor and the ligand, and it gives you a interface to do that preparation. Okay, and then you have this AutoGrid 4 and Autodoc 4. These are executable files. Okay, so these are in case of Windows, this is .exe file. Okay, so when you install Autodoc 4, so I've given you the link for downloading and installation, right? So when you install Autodoc 4, in the installation folder where where you have installed the program, you'll find these two files. Okay, autogrid.exe and autodoc4.exe. Okay, so this will be uh, will require this for generating this one for grid map, and this is would require the receptor dog as well as your ligand. So this, for our example, we are going to download from PDB. So I already have the PDB ID for the acetylcholinesterase, right? Acetylcholinesterase complex with the drug molecule donepezil. Okay, this is from human. Okay, so the PDB ID for that is 4EY7. So how many of you are having trouble in installing MGL tools? Oh, Ayush, you are having. So what is your system?
Yeah, so my system is Mac, and I tried with VirtualBox as well, but it's not working.
All right. So yeah, if you go to their website also for MGL tools, they have clearly mentioned there that they will have problems with Mac, and if you have previous versions of Mac, it is working. But
Yeah.
yeah. So I would suggest you to use some other system, and also even with the AMD processor, it's giving problem. Okay, system with AMD Ryzen some processor is there, right? So those system with the AMD, they are also giving problem. So these are open source tools, and you see, I'll show you one stats. Okay, so this is a paper where it have collected data on the number of publications, or how much publication are done using different tools, right? So this is Autodoc, and in 2020 you have 49% of the publication that were using molecular docking was done using Autodoc. Okay, so this is a very popular and very trusted software, but they also have some shortcomings. So it is not compatible with all of the systems software which is used for publication. uh, Processor are Intel, and even though Mac also, if you have Intel processor, then it works, otherwise the latest, right? So these are the formats that we required. And PDB, of course, will be downloading from protein data bank, and it accepts the protein data bank format for preparation of the receptor and the ligands. And then we have to convert the format, the final processed receptor and ligand, to PDB-QT format. So only this format is accepted by Autodoc 4 as well as Vina for doing the final molecular docking run. Okay, so we have to change or convert to this particular format. And then when you are uh, preparing for grid map generation, we have to generate an input file known as the grid parameter file. Okay, and then the final file for after running the grid, the after generating the grid, you will be having some other files, okay, grid map files, and also a file name as the grid log file, where all the information about how you have generated will be stored here. Okay, and then you also need a file, input file for final docking. So that input file will be docking parameter file. All these files will generate in the subsequent steps. Okay, so the final doc file after doing docking will be docking log file. So in this file you will be getting the scores of the conformers right after doing the docking, and the x, y, z coordinate of all the conformers. Okay, so this is the workflow. So we have to prepare the again. So now you might want to ask, like, if we don't have the co-crystallized ligand like what we are going to do now, what then? Okay, so in the subsequent sessions we'll be taking an example where you don't have the co-crystallized ligand. So we'll be predicting the binding site, as well as we are going to do docking with some other unknown molecule for that. Okay, so don't worry, just think, let's take this example first. Let's do this example and follow the steps, and let's have a command over the basic steps. Okay, so once we are happy with the execution of these basic steps without error, you can again jump into that this uh, I mean whatever advanced steps, okay, like how to predict the active site and how you can do docking with unknown molecules. And also, if you want to prepare something like this with your own receptor, we can start using your own receptors. Okay, but for now, just focus on the example that I'm giving you. And if you are able to do the same steps that I'm doing now and without error, then you can go with your receptor, okay, with your own receptor or the target molecule. Otherwise, uh, without preparing and doing the steps that I've given you here, okay, without practicing, if you jump to your receptor, it may create some kind of uh, error, or you may have trouble running the steps. Okay, so sometimes it demotivates you. So first, if you are able to do it properly with the example that I'm going to give you, it's kind of give you motivation, okay, to do further with your own risk. And then we have to remove unnecessary chains that we are not required for docking, remove the water molecules, add polar hydrogens, and assign charges. Same thing for ligand. So for ligand also, you have to add polar hydrogen, assign charges, assign number of rotatable bonds. Okay, so for now we are going to just use default option for this rotatable bond also, but once you are confident enough to execute all the steps, you can play around number how to change the rotatable bonds and all, so many parameters you can play around, but let's use the default option for this examples, and then when you are confident enough to do it, so you can play around with the other parameters. Okay, so we have to convert this to PDBQT format, receptor as well as the ligand, and then if you are doing the targeted docking, then you have to define the binding site. So you will be having some kind of grid box, okay, to define the enclosure. Okay, we'll be doing this also. So once you have the grid box, then you can once you define the grid box, you can run the grid files, or you can do the execution of this grid auto grid command, and then you can finally you will generate the grid map. Okay, so this will generate the input file and you will get the final information about the grid map. Okay, so once you have the grid maps, you can then run the final docking. So for that file, and you will get the final information about the grid map. Okay, so once you have the grid maps, you can then run the final docking. So for that, you have to define what are the algorithm that you want to use for running the final docking, and before that you will be generating a input docking parameter file, and then when you run this particular command or this file, executable file, you will be generating the final docking, okay, results. So in this you will get the confirmation about for the docked molecules as well as their scores. Once you have the run this and then when you got the results, you can analyze the docking score as well as the interaction analysis. Okay, so to do the interaction analysis, I have given you a program called Maestro. Okay, so many files, I mean many softwares are there, like Pymol is there, then what Discovery Studio is also there. Okay, Chimera X is also there, but you should keep a program which is uh, comfortable with you. Okay, so Maestro is somewhat it's user friendly, and it is for me it is I'm comfortable with Maestro. Previously I was using Pymol, but Pymol is now you know um, taken over by Schrödinger, and though they have the academic license uh, for publication and all those, Maestro. Okay, all the feature that is present in Pymol, it is also present in Maestro, and for publication, figure generation, Maestro, we can use it for free. Okay, for academics. So please install, if you have not installed Maestro, you have to have academic email ID, and then you have to create an account, and once you have created an account, they will send you the link. Let me know. So because this publication ready figures, okay,